Hello, everybody. Brian here, quantlabs.net. Wanted to go over this article sent from our usual same source. This is an interesting article. I did post an article or Reddit post about C++. One of the suggestions was, what is GPU programming? CUDA, namely from NVIDIA. There was a link to it, and it specifically talked about what quant finance does with it. So you might want to check that out. That was posted yesterday on August 19th. So this one specifically from Red Hat, and I want to go over this because I think this seems to be a little bizarre. And there's going to be some HFT kind of stuff to it. So if you want to get that book, C++ HFT ebook, it's out. Just sign up here. I don't release information. You will get the link to the book. I think it's in a series. It might be 1 or 2 days before you get it. If not, you can just go into the share uh, in the share under here under more, and you'll find it under file share. And boom, there it is under the PDF. So you can get it there, but you got to still sign up. So um, okay, so let's talk about the GPU programming from Red Hat. Now, remember, Red Hat is owned by IBM. IBM, I can tell you, has been specializing in other areas that you may not be aware of throughout the Mideast, throughout specialized projects in India, and the software usually will be probably a preferred OS of Linux, Red Hat. So this will be part of it, and let's see what they say. All right, this guide will help you get started from the GPU graphical processing unit programming, otherwise known as GPU, tended to teach you the basics of parallel GPU computing, such as the SMID model. That book here, again, under the learn here at quantlabsnet.com. Sign up. You'll get that in the book. You'll mention it as well. Some of these other things, walk you through some key algorithms. It's always basic: the quick sort, a scan, prefix sum, and game of life. To me, quick sort's always been around for a long time. Show you working examples of code from OpenAI Triton, CUDA, which is the NVIDIA OpenCL, Torch Compile, Numba, and HIP HCC. So you have all these different frameworks here. Help you determine which framework to use and go over the common pitfalls. So in here in the keywords, you'll see it is C, C++, and the different compilers. So usually that's where you find that. Okay, so what is GPU? It's a special massive parallel processor, originally for a gaming with NVIDIA. That used to be under, I think it was AMD for quite a while, under the brand name of the GPU boards for gamers to speed up their systems using this specialized parallelized processing. Is much slower and simpler than a CPU. Uh, so it has its own dedicated memory. So when the CPU comes to single threaded operation, you now have tens or even tens of thousands of individual threads. That's on the smaller GPU boards, and as they get bigger and scale it out, maybe the $40,000 GPU sets, I guess you call it, they're pretty big. Um, Tesla, or I'm sorry, Elon Musk for his XAI did put major big orders on that, and that he's been training a lot of the XAI on that with the new Grok 2. So this comes from for Elon Musk in his new data center in Memphis, Tennessee. A lot of that's coming from these boards. So if you got the cash and you have the access to NVIDIA to get the orders in to get these kind of boards, you could do the same thing. I'm sure you may get some questions from the government going, "What are you doing?" You know, "Oh, nothing, sir. I'm just building a little oh, never mind. Each GPU core stream multiprocessor SM essentially use a mechanism similar to a CPU SMT to host potentially thousands of threads at once. So if you're using C++ and Linux, Windows, preferably Linux, reduces all the jitterness and all that stuff out in the OS. You'll get better processing speed. So the example, NVIDIA A100 has 2048 threads per SM, single multiprocessor, and 108 SMs, resulting in only 221,184 individual threads. Wow, that must be a pretty expensive board. GPU programming model. So a lot of finance is using this, I'm sure, for Monte Carlo, probably building out AI models to try to project and analyze their markets, namely probably in forex currencies, options, futures, you name it. Luckily, the developer side, we don't have to manage hardware as such a low level. We lay out the program as a grid where each block in the grid works on its own SM and has its own dedicated memory. Within each block, we have a number of threads is laid out in a grid that will simultaneously execute or program, which we call a kernel. Um, so that's similar to like the Linux kernel, I guess. That's what it sounds like. When we decide on such a layout, we can largely rely on whatever uh, layout is most intuitive for the problem at hand, and the hardware driver will take care of the rest. We use more blocks than available SMs, then those remaining blocks will simply be queued and run soon as existing one is free. So when it comes to HFT, if you read that book again at quantlabsnet.com under the Learn tab, what you'll know is in there it describes everything. So you have offloading and onloading on your core PC because the processing is totally different on each. Again, I'm no expert here, but I can give you the general consensus. And there's also the different types of memory caches as well, which I don't think the GPUs offer you. Again, I'm not these nerds going down to this level. Like to do that, but time is never on my side, of course. If we use more blocks in SM, then those remaining blocks will be queued. If we use more threads than available, then those existing threads will be queued up as well. So part of the thing when it comes to HFT stuff, you're trying to remove as much of this queuing as possible because that is what builds in your latency, which you don't want. These are certain performance benefits from benefiting a block size and tuning the grid parameters. But at high level, we get a lot more freedom for how to conceptualize and design our algo. Oh yeah. So that's again like Monte Carlo simulation comes to mind for this sort of thing. Device, grid, kernel. Part of the reason the GPU is able to handle so many threads is because of its limited capabilities instruction set. Rather than doing branch prediction, a GPU will simply choose to switch to another thread and continue executing while waiting. GPU, why we don't branch predict. So the GPU is able to constantly keep its powerful backend fully saturated, hence the performance is massively parallel um, operations. Unfortunately, comes at a cost. If you take a look at the diagram, you'll notice that there are two rows, one for the device, which is a term we usually use when describing the GPU, and one for the host, which refers to the CPU. So that that's what I'm saying. The CPU is the local on the machine you're running, and then there's a GPU itself, which is now a separate board as well. GPU is the most called the host, main device, and it issues the commands. GPU programming this limited instruction set means that most GPUs don't support recursion, and some don't support arbitrary loops. So they don't allow it, I guess, in OpenCL. My own testing I found that putting a loop inside a conditional was forbidden on certain systems. If X equals 0, then J is less than K. All this means that we must constantly coordinate our algo on the CPU side. Boom. So all that processing can be done on the CPU. You can almost conceptualize GPU as the device that only runs a fixed, finite, predefined list of instructions every time the host launches a kernel. Of course, this is changing, but the basic model still holds for the lowest common denominator of devices. So this article was written, not too long ago, So this concept probably still is in play. Um, okay, luckily, by leveraging the host to run multiple GPU programs back to back, we can still use Turing complete computations. So Turing is where I'm no expert here, but I've been watching the Sam Altmans, the Eric Schmidts, as I said, and there's a certain level where the thing becomes ascension, right? And is able to learn on its own. Again, try to find those interviews. Best way to do this by running exact kernel program on a bunch of elements at once, repeating this process, switching kernel as many times as we need. Hence the name of this programming model. And again, this is now mentioned in the HFT book, single instruction, multiple data, or SIMD. Let's see. Oh, we're almost done, which is good. Okay. Um, one caveat is on certain NVIDIA devices, we can use dynamic parallelism to do this instead, completely bypass needing to return back to the host. Essentially, you can write a CUDA program that uses recursion like you would on a GPU, and the device will automatically take care of the work launching a series of kernels for you. It must be fairly advanced there. And paying more of this. Uh, quick sort can be done with CUDA. As an example here, let's just take a look at this. Probably done in C++, of course. Quick sort, da 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 da. Oh, yes. I'll be just interested to see if it's let's see, with dynamic. Let's see if it's coming up on GitHub. C++. There you go. Boom, boom, boom. All right. So continuing along. Um, so because it doesn't have to wait for the host to launch new kernels, it's faster and easier to code. But it's computationally equivalent to simply launching a series of kernels, and it works on NVIDIA CUDA only because that's proprietary. One thing I could say, I've said this a few times, is MATLAB's very good at this. You can do all the coding within the M script of MATLAB, and all this complexity is done for you behind the scenes, and the coding is very fast. So, to look at something like MATLAB or including on the quant stuff, it might be interesting to invest the time to look at that because the CUDA might not be any different in terms of processing time, C++, Python, Java, and even MATLAB. So if that's the case, MATLAB might be good to really focus on because you just focus on the code instead of the code behind of all this CUDA stuff. Uh, First contender to truly take GPU seriously was NVIDIA with CUDA. After that, Apple began to create a competitor called OpenCL. Working with the Kronos group, the group that brought you OpenGL and Vulkan, soon became supported by other vendors like Apple, IBM, Intel, and now is the most widely supported compute framework in the world. That might matter, and I think it's open source. Again, I'm no expert here, but I'm in a way. OpenCL was always behind CUDA in terms of features and developer. Also, both frameworks are known to have steep learning curves. Sounds like Torch or Tensor for the ML, for the machine learning. And you might be reading this guide. So, two problems have spawned a large number of alternatives to CUDA. Many of these eventually were abandoned. This is the problem if there's no corporation behind it, because it does get abandoned and then it loses its obviously momentum. You put your time into it, now it's abandoned, then you're like screwed like the pooch, right? Which you don't want. So yeah, you may have to go with the bigger ones, sadly. HIP, HCC, ROC, AMD competitor that attempts to open source it so it can be used everywhere. And again, attempts. Okay, that's the key. Open one API Intel competitor that attempts to open source so it could be used everywhere. Attempts. Okay. SYCL, new compute language framework created by Cronus in response to OpenCL, outdated. Vulkan Compute, new compute language framework created by Kronos in response to OpenEL, outdated because it's probably abandoned. Metal, Apple Compute Framework, which is still used for ML development on Apple devices. So if you're okay with that, maybe continue using Apple. I'm right down to a 9-year-old iPhone, and that will soon be gone. I'm just done with Apple for a variety of reasons. I'm sure you're probably in the same camp on. I like open source. I like my Linux, and I don't like to, as we're moving to be controlled by these tech companies. High level languages focus on GPU, Open AI Triton. That could be something to watch out for. Torch Compile, Julia GPU. That could probably get abandoned as well. Julia's not taking off like it used to, and then Turbo JavaScript, probably the same. We will discuss some of these later in other articles. So it's a 4-part series. Be on the lookout for that. So again, I'm just touching on this. GPU, if I was to put money onto uh, a racehorse, yeah, I'd probably go with Nvidia just based upon when you look at how big the stock is of Nvidia. It's a powerhouse right now, and they ain't going anywhere anytime soon. So that might be a better option for you, and it may be pretty good as an option for career, especially if you're in the world of finance. So we'll leave it at that. Again, if you want to get that C++ HFT book, just go over here to quantlabsnet.com. It will be in the description below. We shall talk to you later. Thanks for watching. Have a good day.